Welcome to Train Signal. You're watching a lesson on the different types of networks. Now, there are three main sections that we're going to have to this lesson. The first one I like to call LANs, WANs, and automobiles. No. That's just a little joke if you've ever seen the movie Planes, Trains, and Automobiles. But basically it's LANs, WANs, and, well, so much more. It's LANs, WANs, MANs, CANs, PANs. There's all kinds of ANs. And so we're going to take a look at those here. After that, we're going to take a look at something called network topologies. And then we'll wrap things up by looking at internet connectivity, those types of networks. So first, let's take a look at all of our ANs. Which, by the way, the AN part, AN, is area network. And that's going to be true in all of these. And the first one I have here is a LAN. That's probably the most common AN that we hear. A LAN stands for local area network. It means just that. It means a network that is, well, there's a lot of, differences of opinion on exactly what makes up a LAN, but basically it means one network contained within a building. That's the illustration I have here. Sometimes even within a building, they'll say if it's on a certain subnet. Remember in a previous lesson I talked about the different types of networks and they need a router to go to another network. And even within your company, within your building, you might have these different networks and they're called subnets. Some people think the individual subnets are a LAN. I wouldn't get too hung up on it. The bottom line is if you think of the name, local area network, it means just that. It's local. It's a small localized network, typically within a building. From there, if we expand out a little bit, we can have something called a CAN, C-A-N, which stands for Campus Area Network. And if you know what a campus is typically a series of buildings that are all on a single property, right? A series of contiguous buildings. A campus area network is just that, a network that broadens out beyond just one building, but it still stays on a single property within a single campus. Now, if we broaden out from there, we move to something called a MAN. The Metropolitan Area Network. Now, this is something that we don't refer to too heavily anymore. This had a lot to do with back in the day when we were still using telephones, like actual landline telephones all the time, and we had local calling and then long distance calling. Well, a metropolitan area network was where we had a network that spanned beyond one building. And it was even beyond a certain property. It was a bunch of buildings, but all within a single metropolitan calling area. So if it was still a local call. And the reason I say that this is not really talked about too much anymore is, well, first of all, in general, we don't use a lot of landline calling anymore. And even when we do, the whole local versus long distance thing, yeah, we still have some plans in place, but a lot of calling plans these days are just kind of a blanket across the board, call wherever the heck you want. The second thing is that we don't use dial-up to communicate from one office to the other. We typically will use the internet. So again, it's not going to cost us any more to communicate with the building next door as it will to a building across the country. Possibly, okay? Again, the reason I'm still explaining I still have metropolitan area network listed here, is there are certain circumstances where it could matter. But if we branch out from our metropolitan area network, we then move into our WAN, our wide area network. And I will tell you that LAN and WAN are the two most commonly used terms. LAN for the local network. Yeah, we have these in-between campus and metropolitan area networks, but the WAN, the wide area network, means just that. It's wide. It's spread out. The example I have here is I'm showing, well, I guess what is a picture of the United States. And I did my best to put some offices. Looks like I have one in Chicago, one in Dallas, one in New York, one in Los Angeles, and one in Seattle, I'm guessing. And the idea is you now have those offices all connected together, communicating with one another. That's a wide area network. Now, there's a newer one, and we're not spanning out now. We're actually, if anything, going to shrink it all the way back into as small a network as possible, even smaller than the local area network. And it's the PAN, which stands for Personal Area Network. And this is very often considered to be kind of a Bluetooth-based network where you are communicating with just a series of devices that are all in very close proximity to one another. And some people even say that a personal area network means things that are on your person or within your own personal workspace, on your desk. So we're saying you might have a computer. I know in this particular drawing I have 2 laptops, but let's say one of them was a computer, one was a laptop. I have a printer on my desk, I have my cell phone, a PDA, my mouse, a wireless headset, so on and so forth. These things are all connecting via Bluetooth. They're all part of a personal area network. So those are a chunk of the ANs that you need to be familiar with. There are actually more if you really wanted to go crazy with it. LAN and WAN are the 2 most important ones to know. Local, meaning a localized network, typically within a building. Wide area network, meaning wide, spread out. Moving on to the second section of this lesson, let's talk about, I mentioned the term network topologies. The funny thing is everything we talk about in this lesson could be considered to be part of a network topology of sorts. Here I want to talk about the actual physical network topologies. Now, what is that term topology? What does that mean? The topology is the actual layout of the network. And you'll notice, by the way, that even though I called this section physical topologies, you'll see here that I tell you that a topology can be physical or logical. We're going to see that. We're going to see as we go through some of these standard topologies, that in some cases it represents a logical topology while the physical topology may be different. That means that logically the layout of the network works one way while physically it looks another. Okay, so the network topology is the actual layout of our network. And I have some diagrams for you here, but don't worry about it because we're going to touch on each one. The first one that I have here is something called the bus. Now, this is an older topology that we don't see used very much anymore. We used to actually use coaxial cable for these bus topologies, and all the computers are connected on a single cable in a straight line, kind of like as you see here. Some of the specifics are you had to have terminators at the end of the bus segment, and the reason why is because Electrical Engineering 101, when a signal is traveling along a cable and it gets to the end of the wire or the end of the cable, it bounces back, and it'll keep bouncing back and forth until the signal attenuates. Pretty much, it dissolves over distance. Well, that's a problem if you have all kinds of signals that just keep bouncing back and forth, back and forth, back and forth. So you put what's called a terminator at the ends of the cable, which will then absorb the signal, right? So one computer transmits, it goes out on the cable, all of the computers see the signal, it gets to the end, whoop, terminator takes care of it. If you have a break in the cable, you've taken down the entire network, not just, if you broke this cable right in half, it's not like computers on one side could still communicate and computers on the other side could still communicate, but they can't all communicate with each other. No. Breaking the cable takes down the entire network, and the reason why is because you now have an unterminated end of a cable because you broke it. And you didn't throw a terminator on, you just broke the cable. The next physical topology I want to talk to you about is something called the star topology. In a star topology, all the computers are connected through a central connection point, or what's sometimes referred to as a hub. Now, we'll talk about networking devices like hubs in a different lesson. But the idea is, as you see illustrated here, you have all your computers connected to this central point to make what kind of looks like a star. This is one of the most popular, most heavily used networking topologies. A break in the cable, or one of the cables, will only take down communication to that one computer. Okay, so if you break the cable, just the one computer connected to that cable loses communication. It's only if the central hub were to fail that your entire network goes down. So you can see the benefits here of this type of network as opposed to the bus. And I will tell you that this type of network is also would use your twisted pair or Ethernet cables. I can also tell you that the hub, which is a very, very old device, old from a technological standpoint, is replaced with, these days, something called a switch. And again, I don't want to get ahead of myself. That's a different lesson. But the switches also allow for very efficient communication back and forth between these computers. Because with a hub and a star topology, the way it works is one computer would transmit, it would go into the hub, and then it would be retransmitted out to all other computers, even if it was only meant for one other computer. So it's not very efficient. Whereas the switch, which is a newer device, would allow a computer to transmit in, and the signal would only then be sent out to the appropriate destination computer. But let's reel this back in. Let's talk about topologies. The third topology I have here is something called the ring topology. And in the ring topology, all the computers are connected, just as you see illustrated here, in a circular fashion. Data is passed around the ring from computer to computer. A single break in the cable would take down the entire network. And the reason why is because data travels in one direction around the ring. If the cable were to break, you can't just suddenly have computers bouncing information back and forth in a different direction around the ring. Data needs to travel around in one direction in the ring, and if it breaks, you don't go anywhere. Now, the most typical form of ring network is something called a token ring network. And a token ring network is one where it is a logical ring. Again, I mentioned that a topology can be physical or logical. Well, the picture that I just put up on the right would be a token ring network in which the data logically moves in a circular fashion around the ring from one computer to the next. And it uses something called token passing, which I'm not going to go into detail with you here. But the idea is the token passing is how you determine who has the right to send data. That data travels all the way around to all of the computers. In this case, in this picture, it would be all 4 computers. And then the token gets passed to the next computer if it wants to transmit. Everybody gets to take a turn. But here's the deal. It's a physical star topology where you have a special device in the center called a multi-port access unit, a MAU, or even sometimes a smart multi-port access unit, SMAU. And the idea is that unit is just a wiring box that data travels in and out as information gets passed from computer to computer. And this way, a single break in the cable does not take down the entire network, especially if you have a smart multi-port access unit, which knows to close off that port if the cable breaks and allows the remaining computers to communicate. Another type of network topology is something called the mesh topology. And this is a topology in which all of the computers are connected to all other computers. Typically used in a WAN environment. That's why I have 2 illustrations here. I have the very basic one, which shows 4 computers, and they all have a cable connected to each of the other computers. And then I also brought up that WAN picture that I had of the United States with our 5 offices. Notice that you have a connection line going from each office to each other office. The idea behind the mesh topology is in the event that you have a connection failure, you have fault tolerance. If the connection between Chicago and New York was to go down, no worries. Chicago could still communicate with New York. It might have to go via Dallas or via Los Angeles or via Seattle, but there are other connection mechanisms to get from one office to the other. And that's where you would typically see your mesh topology. So now that you know these 4 types of topologies, the bus, star, ring, and mesh, you need to understand that in the real world, you may see a hybrid of these various topologies, right? Like here, again, it's not necessarily a real network, but it's an illustration. You'll see that I have 3 different star topologies, and the hubs on these 3 star topologies are part of a bus. May not be the best example, may not be the best drawing, but it gives you the idea that you can have a variety of topologies all working together and take advantage of some of the benefits and the failures of each. So the last section in a lesson here where we talk about different types of networks is we need to talk about internet connectivity, because that's the type of network, right? The internet. And bringing your network connectivity to that other network, that's the type of network. So what are all the different ways that we can get connected to the internet? Well, one way is through dial-up, using POTS, plain old telephone service, or what sometimes is called PSTN, Public Switch Telephone Network. And using a device, which again, we'll talk about devices in another lesson, but a device called a modem, which by the way, modem actually stands for modulator demodulator. It has to do with the conversion of digital signals to analog signals that are used over the telephone lines, and then demodulating from those analog signals back to digital signals. We don't use this type of internet connectivity very much anymore. Another one that we don't see used too heavily anymore is something called ISDN, Integrated Services Digital Network. Here's the main thing I want you to know about ISDN. It had two flavors, BRI and PRI, which stands for Basic Rate Interface and Primary Rate Interface. Your Basic Rate Interface used two 64 kilobit B channels to transmit data, and it had one 16 kilobit D channel to transmit control information. So your basic rate ISDN would get you about 128K. Hey, when it first came out, that was considered fast because the fastest thing before this was dial-up. You know what those dial-up modems capped out at? 56K. And yes, I'm saying K as in kilobits, as opposed to in today's world we talk about megabits, and in some cases gigabit. All right, so we're talking really slow here. Even the primary rate had 23 64K B channels and the one 64K D channel, and it gave essentially the same throughput as a T1 line, which was basically 1.5 megabit per second throughput. I remember when that was considered really fast. I remember being excited to go to work because they had a T1 line and I could get on the internet with 1.5 megabit as opposed to 56 kilobit at home. Okay, so primary rate ISDN was really fast. Now here we have our digital subscriber line, or DSL. Where do we primarily see this? We primarily see this in home networks, getting connected to the internet. Provides high-speed internet connections using standard copper telephone wires. That's what made it so popular for the home networks. You already had telephones in your home. How cool would it be if you could get high-speed internet? Forget that 56K dial-up. You could get high-speed internet using your telephone lines, depending on what you call high-speed. Again, the original DSL, high-speed was trying to get you up in the area of that T1 line. I mean, in some cases, it was like getting 384K instead of 56. Hey, that was high speed. Now, DSL comes in many different flavors. We have ADSL, which stands for asymmetric DSL, which allows POTS, remember, plain old telephone service, and data to be transmitted simultaneously. You have SDSL, which is, instead of asymmetric, now it's symmetric DSL, where it cannot share that data transmission with POTS. And probably the most popular flavor today, which is VDSL, which I love what it stands for, very high speed. Should it be VHS DSL? And I think the problem is they don't want to go with VHS because that makes you think of videotapes. So very high speed DSL allows to the maximum bandwidth available over a standard phone line, which actually was pretty fast, much faster than they ever thought it could be. You could get, in a perfect world, a little over 50 megabits per second. That's pretty good for internet. I don't get 50 megabits per second today on my internet connection. There's very few internet connections that I've ever seen getting that fast. In a perfect world, you could actually get that via your VDSL. That's why DSL still exists in today's world. The other thing I can tell you is that the DSL providers also figured out a cost-effective way that they could use fiber to help get you onto the internet. We have something called fiber to the node, FTTN, and fiber to the premises, FTTP, which is an idea where they go ahead and use fiber to either a network like in your neighborhood, or even with fiber to the premises where fiber goes right up to your house. And then from there, you could go ahead and use internal Ethernet cabling to be able to create your own internal network. And the idea here is, if you remember back to the different types of cable we were first talking about, remember fiber is very fast. Okay, so companies like AT&T, at least here in my area, they offer these different fiber options to try to compete with the different cable companies. And speaking of cable companies, that's another way we get to the internet, via something called cable modem. Getting high-speed internet using broadband cable connection, right? So you got your cable TV, using those connections. And by the way, your cable providers also have figured out how to incorporate fiber, at least to the neighborhood. I don't think there's too many cable, if any, cable providers who are giving you fiber to your house, but you get fiber to the neighborhood so that you have a real high-speed trunk line, so to speak, and then you have the actual coaxial cables that are going to your homes. You have satellite, which is used to provide a high-speed internet connection, typically if DSL and cable are not an option. Okay, you have a few, outlying areas where there is no DSL or cable provider who's willing to invest in the infrastructure to get you high-speed internet that way. We got all kinds of satellites floating around the Earth. So we go ahead and we use those satellites to get onto the internet. We have wireless, which, there's a whole variety of meanings behind wireless. I have here used primarily by mobile users through the use of either a Wi-Fi hotspot, right? Like you go out to your favorite coffee house and you connect via that kind of wireless to get on the internet, or maybe through the cell phone network. Speaking of the cell phone network, we have our 4G technologies of WiMAX, HSPA Plus, and LTE. And I'll tell you what, in a course that I did not that long ago, I added on to that how WiMAX was a technology that Sprint was primarily using, and HSPA Plus was something that big carriers like AT&T and T-Mobile were using, and LTE was primarily what Verizon was using. Okay, so those are just kind of the 4 major cell phone carriers, at least here in America. But I will tell you that even that, I've removed that from this slide because it's not true anymore. An example I can give you is I happen to use T-Mobile, and I'm now on an LTE network. I'm not going to go into all the various ins and outs of what WiMAX is versus HSPA Plus or what LTE is, but these are competing technologies that each claim to be the best, the fastest, the most convenient. And there is one last thing here. I know they listed it on the CompTIA objectives. Line of sight wireless internet service. This is actually kind of interesting. Something that's been around for a long time. It didn't take off the way it was originally. The first companies I saw doing it, I actually knew a couple of guys who they were trying this idea. The idea of basically saying, what if I set up a real high-speed connection, right? And it's quite costly. They were setting up like a T3 connection, which was getting them 45 megabits per second. This is back in the day when T1 was considered really fast at 1.5 megabits. So they'd have this 45 megabit pipe coming into some office building. And then at the top of that office building, they threw up a big antenna. And then they would use wireless, like we talked about in the wireless lesson. And as long as you and your company had your building had line of sight, which usually was about, believe it or not, you could get about up to 25 miles, as long as you didn't have any major structures in the way. So if you're out in like different big high-rise city areas, or if they weren't very foresty areas, although you could get, I actually saw one where they put an antenna on top of a tree, I guess, in a forest. But basically, the idea was your company could then, via that wireless connection, get a piece of that high-speed connection that they had in that one central building. Now, we still see a little bit of that today. There's a company near here called Clear, and Clear Communications, they offer via WiMAX, okay, so they're using the cellular WiMAX technology, if you can get line of sight to one of their towers. That was a kind of a quick and easy way that you could get high-speed internet, and you could get 5-6 megabits, pretty easily, as long as you had good line of sight wireless access, when I say wireless access, I'm saying you could actually see their tower. So that's another way of getting on the internet. And that does bring us to the end of this lesson. As we learn, there's all sorts of different types of networks. I mean, first of all, there's the LANs, WANs, and, as I joked at the beginning, automobiles, right? You have your LANs and WANs and CANs and MANs and PANs and all the different ANs. You have to know them. You have all your different topologies, which stand for the actual layout. And then we have internet, that big network, that World Wide Web that we want to connect to. And we have many different ways of making that connection. And you have to know all of this. So, I thank you for watching, and I will see you in the next lesson.